Thank you so much for the invitation. So I'm supposed to talk today about the enzymes, and in particular we are going to address the questions how monoamine oxidases work. So this is our laboratory. I'm coming from the National Institute of Chemistry, so this is an institute of nearly 300 people. And in particular, in my laboratory, we are dealing with biomolecular simulation, and computers are our main tool. So we would basically like to answer questions how biological macromolecules work and what's their function. So it basically all started in the 90s since I spent at the University of Groningen nearly 3 years working with Herman Berentzen. So he was at that time president of the International Union of Pure and Applied Biophysics. So this photo in the middle, that's in a wine cellar close to Novo Mesto. It was a summer school, good times. So enzymes are basically macromolecules, mostly of protein nature, and they work as biocatalysts. So they increase the reaction rates. They are big, they are complex, and nature didn't choose them for fun to be so complex. Let's define what's catalysis. So catalysis just means that we are lowering the barrier for the reaction relative to the, let's say, reaction aqueous solution. And if this hill is lower, then it's easier to trespass it and the reaction proceed faster. So catalysis is about cats. Well, question is, what are the factors that are responsible for enzyme catalysis? Pauling rationalized that, you're going to lower the barrier if you're going to solvate the transition state more favorably than the reactants. Well, as solvent, he considered enzyme environment. And then it took some time before Arya-Worshel recognized that the pre-organized electrostatics is the only relevant factor for enzyme catalysis. So if you know something about the transition state, then you can design analogs of the transition state, and these are wonderful inhibitors. So most of the drugs are inhibitors of the transition states. Pre-organized electrostatics means that we have a bunch of charge groups around this active center, and they communicate via long-range electrostatics. This is the reason why you cannot design enzyme that will consist of just few residues. You need this huge structure. That's a possible explanation. Well, monoamine oxidases metabolize dopamine and serotonin. So bad news is that hydrogen peroxide is produced as a byproduct, and this is responsible for oxidative stress. It took us quite some time that we realized that the rate-limiting steps represents detachment of the hydride ion from this vicinal group that is picked up by flavin moiety. It brought us a cover page in EJOC very recently. So then we, of course, carefully included the environment, and we realized that in the gas phase, this reaction would take forever, very high barrier. In water, this is lowered for 5 kcal, while if we include full enzymatic environment and perform proper averaging, we obtain fantastic agreement with the experiment. So we included full protein environment. Unfortunately, these movies do not work since we don't have perfect agreement between there is no fine compatibility between Microsoft and Apple. So this is the gross picture, where most of these monoamine oxidases are actually located in the gastrointestinal tract in order to prevent entrance of the unwanted amines like tyramine to intervene with the human body, but still significant part is found also in the brain, and here they are basically responsible for breakdown of dopamine and serotonin. And obviously, if you have these guys are too active, you're going to lower their levels, so not much of the dopamine will reach dopamine receptors, and such people will be depressive. On the other hand, if you would increase the level of dopamine by blocking the dopamine reuptake, this is called that we are sniffing cocaine, or kids are taking amphetamines. If I would have high school kids now in the audience here, I think they would probably ask for more explanation. But in any event, bad news is whenever you are going to degrade dopamine or serotonin, you will get hydrogen peroxide that will go and will start producing the amyloid plaque. So you will get sick neurons that will gradually die, and this is called neurodegeneration. So cigarette smoking helps because you are going to block monoamine oxidase with nicotine, while also one of the unknown substances in tobacco smoke out of 900 would go and irreversibly inhibit MAO. So at the age of 85, nearly 50% of the population has developed Alzheimer's disease, while only half of them in the case of smokers. So smoking is beneficial. Also drinking of wine is beneficial because it will pick up those scavengers. So what are the perspectives? So we can predict effects of point mutations, and we have potential to understand depression and stuff like that. Okay, here I would like to thank also my coworkers, and that's it.
Thank you very much, sir. But please don't leave the stage. Now, is the innovation itself also that smoking and drinking helps? Are there any limits to that? The more you smoke, the better it gets, and the more you drink, the better it gets.
No, the idea
is there a limit?
Thank you. So the idea is if you would smoke one cigar per week, this would be fantastic.
One cigar?
One cigar per week.
Okay, and now let's go to the wine. How much wine?
I mean, a glass of red wine per day would be beneficial.
Per day or per week?
Per day.
What about 3 glasses?
That's a bit too much.
Oh, come on, sir. Thank you very much.